Welcome to my first lab video report. In today's lab, we intend to investigate the charge of simple household objects through qualitative and quantitative methods. Using a clear Scotch tape, the objectives of the experiment were to charge the tape, interact the tape with other items and record all observations, calculate the charge using key physics concepts, use glowcript to represent the forces. By the end of the experimenter should accurately report the charge of a piece of polarized tape, the number of electrons the tape is deficient of or in excess of, as well as the ratio of the number of electrons involved to the total number of atoms on the tape. Before charging the tape, the experimenter would need the following materials: a roll of clear Scotch tape, a few thick books, a ruler, and a flat surface like a desk. After collecting the materials, the following procedure was done. Around 20 centimeters of tape was rolled out and placed on the flat surface. This was the base tape used to charge all pieces of tape rolled out subsequently. After rolling out another piece of tape, a handle was created by folding one end of the tape. This tape was smoothly placed on the base tape and with a quick motion was pulled off. To know if the tape was successfully charged, the tape was left to hang on an edge of the desk. And after the experimenter's hand was brought close to the hanging tape, the tape should move closer to the experimenter's hand. If the tape does not move, repeat the procedure. The following observations were made. When the hand was placed close to the tape, it was attracted towards the hand. When both pieces of tape were placed close to each other, the tapes repelled. When placing a neutral marker close to both tapes were attracted to the neutral highlighter. However, one of the pieces of tape touched the highlighter. Now, a charge marker was placed close to it, and one repelled or moved away from the charge marker. The deduction: the tape that had touched the highlighter had become neutral and lost its charge, but the other charged tape must be negative since the charge of the marker was negative. The following concepts and formulae were used to calculate the charge of the piece of tape: Coulomb's law, the equation of the electric field of a charge, and Newton's second law. After suspending the ends of the tape between two stacked books, a similarly charged U-tape was placed under the suspended tape. Upon placing tape 2 under tape 1 began to float 5 centimeters away from tape 2. Based on Newton's second law, tape 2 was at equilibrium, which means all forces acting on the system from all dimensions must equate to 0. Therefore, the sum of the electric force and gravitational force equates to 0, and the magnitude of these forces must be equal to one another. By using Coulomb's law and the equation for gravitational force, one would make Q the subject of the equation as seen on the slide. Then it's merely substituting all known values to find that Q is 2.1 times 10 to the negative 8 coulombs. To find the number of electrons in excess on the tape, one would find the ratio of the total charge, found earlier, to the charge of one electron. To find the number of atoms on the tape, one would find the ratio between the area of the tape and the area of one atom. Consequently, we can now find the ratio to the number of electrons in excess to the number of atoms on the tape, assuming that each atom on the tape is similar to that of a hydrogen atom, where one hydrogen atom has one proton and one electron. Just like the process mentioned above, the charge of the tape was calculated based on all known values and inputs. Firstly, all known values were input into the program. Using these values, the gravitational force was calculated and expressed as a magnitude and a vector. Subsequently, the two tapes were represented by two different colored spheres. Using these values, the charges of the tapes were calculated and assigned to the spheres. Using a function created to calculate the force, using the two tapes as the inputs, The electric force on tape 2 from tape 1 was calculated and expressed as a vector. To create the pictorial results shown here, the arrows represented the force were created using the appropriate axes and starting positions. In conclusion, the following results were obtained. The charge of the tape was negative. The charge of the tape was negative 2.1 times 10 to the negative 8 coulombs. The number of electrons in excess was 2.4 times 10 to the 17 electrons, and the ratio of the electrons to atoms was 5.47 times 10 to the negative 7 electrons per atom.